Hey all, and welcome back to Radical Slice. My name is Eric. On this installment, we'll be spending most of the episode on the Zelda-style camera moves when the player moves between rooms. There's a lot to cover in this one, so let's just jump right in. Okay, as for the rooms, let me kind of diagram out what I'm thinking right now. Like I was just saying before, here's kind of like what our structure looks like now. We've got our main, and our player is a top level entity. And right now we have our baddie manager. Let's call it the BM. So in our baddie manager right now, we sort of have the BM pointing to several baddies. And this gets a little bit funky. So we're going to introduce this idea of a room. We know that we want each room to have its own set of baddies, so that when the player walks into the room, those baddies will spawn. And when the player leaves the room, we sort of don't care about those baddies anymore, so we're not really updating them. So there are a couple ways that we could do this. One way I had considered was having the room be sort of like a spec sheet, right? So rather than like the room actually doing any sort of tracking of the baddies, it just like has a list of baddies. So when the player enters the room says, "Yo, baddie manager, like give me some baddies, track baddies at this location," right? And sort of the baddie manager does all of the legwork and tracking. This will work, but the problem is persistence, right? Because let's say we go from one room to another, and the baddie manager is tracking these first three baddies here, and it gets a new room, so it gets a new set of instructions to load some more baddies. Then it sort of has to forget these guys, right? And if we don't have any record of the state of these baddies, that means that when the player goes back to the room, let's say we had killed one of these guys, right? When the player goes back to the room, that baddie's just going to respawn. And so there's no idea of this persistence in between rooms, which is like probably fine for a vertical slice, but also not great. Like it bothers me that we don't have that, right? So I don't want to be bothered. I want to have that sort of persistence. So even though this is sort of maybe questionable from a software design standpoint, what I'm thinking right now is each room will have some baddies. What our baddie manager is doing is just providing sort of an entry point for the update and draw functions and some of the collision code so that main can affect change on these baddies. So we're just going to, whenever the player enters a room, we'll have the baddie manager point to that room's set of baddies. And then if the player were to enter another room, room two, and this also has B3, B4, B5, right? We'll just have the baddie manager now, rather than pointing to this set of baddies, we'll have it point over here. And in this way, we're only updating and drawing the baddies that we actually care about. In terms of components that we're going to need here, we need some sort of like rooms component. It'll probably be like a table or a matrix of room stuff. And then each room will have baddies. And so we'll need some sort of functionality that will do this sort of communication, right? So the baddie manager needs to point itself to the current room's list of baddies. So we'll call that like load room function. Okay, cool. Man, my handwriting is awful. Let me rewrite that more nicely. Load room function. That's like marginally better. Okay, anyway, let's get on with the code then. So let's add our room structure real fast here. Okay, I have created a couple of rooms. One with the baddies at the positions that they're in our current sort of only room that we have, and one with no baddies at all. Also added this item field, which we don't need yet, but eventually the rooms are going to have items, so I just went ahead and added that. One thing that's interesting about the room structure is I went with this sort of 2D array or matrix or 2D vector or whatever you want to call it. It's a 2D data structure. So up until now, we've been sort of indexing tables by saying, if I want the first entry, I'll say table 1 or table 2, etc. With a 2D structure, though, we need to provide two indices. So if we want, I've put our first room, room 0, in the first row, in the first column. So in that case, we would want to say rooms, first row would be 1, first column is also 1. If we had, let's say we'll put room 1 down here. If we wanted to access room 1, we need to go rooms, and it's going to be the second row, 2 there, and the first column there. Okay, so now let's make some changes to main to load this room in. So I've added this current room pointer here in the global scope that will point to the player's current room. Okay, I wrote this load room function that will just take the row and column of the room that we want to load. It will point the current room to that room as long as it's not nil. And it's also going to take the baddie manager's baddies table and point that to the current room's baddies. So that'll handle the situation we said before where every time we load a room, we only want the baddie manager to think about and point to the baddies in the current room. This also allows the baddies to sort of stay in memory. So if the player leaves the room, the baddie manager will forget about those baddies, but the room will not. They'll remain persistent. As long as we don't add too many rooms, hopefully memory-wise, that'll be okay. We'll see what happens. Oh, right, let's load the room here. So in our init function, we're going to load our first room at 1, 1. All right, let's see if this works. I'm not sure if we need to do anything else or not, but let's find out. Okay, well, I guess the room loaded, but there are no baddies. Why are there no baddies? Okay, one mistake I was making was pretty elementary mistake, but in my rooms matrix, I was trying to load room 0 and room 1, but I had them defined down here, which means these were nil initially. Careless mistake. So I just rearranged the code so that room 0 and room 1 get set up first, and then in our rooms matrix, they're down here. So now I think this should work. All right, sweet. There we go. Killed both in one shot. So now we need to figure out how to get the sort of shifting from one room to another, traveling from one room to another, and loading that other room working. So the first thing I want to do is actually increase the size of our current room. Okay, that feels a lot more substantial. We're going to need to include some extra data in the rooms, though, to describe to the map thing where to draw. Okay, one change I made here was to add sort of tile information to our room definition. So we're able to specify where on the map, pull up the map real quick, where on the sort of map thing in Pico-8, which tile to start drawing from, in this case 0, 0, and which tile to finish drawing to, in which case I set 12, 12, but yeah. In this case, I guess it'd be 11, 11. So now when the player enters another room, it'll update the sort of, oh lordy, it'll update the sort of drawing routine. So it's not drawing the same room over and over again. And I guess we'll need some sort of like way to differentiate one room from another. They're kind of bland right now. So let me put something together real quick here. So just to differentiate the rooms a little bit, I just created this extra tile, this floor tile, that we can put on the floor so that we know one room is different from another. Just some sort of visual differentiator. I might change this later. It looks kind of busted, but okay. So I have drawn a few rooms. We got our first room, our second room. I tried to make the second room a little bit smaller than the first one, and then I put a third room down on the bottom here. And I put these sort of passageways in between each one, which should serve as some kind of doorway. I'm not sure how we're going to do the sort of screen, traveling between screens yet, but we'll cross that bridge when we come to it. In addition, I quickly slapped together this item thing. This will be what the player gets when they finish up the room. Now, when I draw these to the screen, I actually want to, right now I've just been drawing sort of the room itself from one edge to the other, but I want to include like the edge. So for example, in room 1, I also want to include this part of room 2 so the player can see it kind of like what's over there. So I want to change the dimensions from drawing from 0 to 12, 0 to, let's say, actually, let's see what this looks like already. Oh, so we can actually sort of see what's going on there. So maybe I don't have to worry about that right now. The player can, however, walk off the screen currently. So yeah, I think that'll work. Let's deal with the sort of drawing dimensions of the other screens or the other rooms when we get there. We do need to add though a room entry for room 3 because we haven't defined that yet, and we need to relocate room 1 to the proper point in the matrix. So oh, right, and let's position them correctly here. So room 1 is here, room 2 is here. There is no room in the lower left corner, which we can see if we zoom out, right? And then we'll put room 3 here. Again, there is method to my madness on this. So let's just load it up as it is and make sure that, you know, it more or less works. Okay, that looks fine. The baddies just kind of wander into the other room, which we'll have to prevent them from doing. That's pretty funny though. So let's see what happens if we load another room. So if we want to load room 2, we have to do this, I think. Okay, great. Yeah, that worked just fine. And then let's try to load room 3, which would be 2, 2. Cool. Yeah, okay, and we got lucky the player just like spawned in the right place. However, the collision is borked. That's because our map offset is wrong right now. So let me fix that really quickly. Okay, yeah, so that's working now. So what I did was, currently when we were doing our player and wall collision, we were just checking the player's coordinates. But that would only be relevant if the player and the map were starting from the same origin, which would be 0, 0 here. Because now we are sort of starting our map in a different place, we have to add a certain value, which would be, in our case, the map start X and start Y tiles, to our calculation, right? So this is a little bit confusing to explain, but when we're thinking of the player's position in relation to the map, the player's position is just kind of based on the screen, right? We can think of the origin of the screen in the upper left to be the origin of the player's coordinates as well. The map is a little bit different, right? Because as we saw in main, we offset what part of the map we're drawing based on the current room's start X and start Y tiles. So if we just compare, let's say the player is at coordinates like 10, 10. If we just check for what's at 10, 10 on the map, the default is that it's going to check up here in room 1, even though we might not be drawing room 1 to the screen on the map, right? In our case, we're drawing room 3. So if we want the player's collision to match up with what's actually on the screen, we need to offset the map's coordinates by whatever we're looking at, right? In our case, the start X and start Y tile for room 3 are, I guess, probably 11, 11. 10, 10, right? So we need to offset by 10, 10 when we do that calculation. And now the player's position is being checked not against the absolute origin, but against sort of like the relative origin of our room. Again, a little bit confusing. I recommend you check the Pico-8 documentation about maps and cameras and stuff if you have any concerns or doubts there. I think the next thing I want to tackle is the movement between rooms, and I've never done anything like this, so I was trying to sort of sort out how we could kind of think about it. It's a terrible drawing, but it'll do for the explanation. So if you've played the original Zelda, what happens when you in dungeons, but kind of in any part of the game, is the camera doesn't work like it does in like a Mario game, right? It's not like a smooth scrolling from left to right or from up to down. It's sort of this quantized motion, right? So when the character, let me do some drawing, look at our hero color. When the character sort of reaches the edge of the screen, let's say they're facing to the right here, right up until now, the camera has been sort of centered only on this room, right? And even though the player may sort of move around the room, the camera doesn't move as long as the player stays in the same room, right? The camera's fixed. The change happens when the player kind of reaches a door on one side of the room. Now, all of a sudden, the camera sort of makes one smooth movement to the next room, and now the sort of camera is centered here. Pretend that's a camera facing downward. I think that's how cameras look, right? All right, so the camera is fixed until the player reaches the edge of a room, in which case it sort of shifts smoothly to the next room. So the way I'm thinking of doing this is using some special map tiles and tying that to collision. So in our room currently, we have these sort of like gray tiles, right? Pretend those are all squares. And the player can just walk on them, right? There's no collision. They're just floor tiles. There's nothing special about them. So I'm going to make some more tiles that probably look identical to those other floor tiles in the map, but we'll only use those tiles indoors, right? So here we'll kind of sketch in a door. And when the player touches those tiles, when we have a collision with those tiles, that's when we'll sort of trigger the camera motion, right? So when the player first steps on, oops, let's use orange for this. When the player first steps on these, in this case, the green tiles, that's when we know we'll make the camera switch here. And we'll also have to sort of cheat the player's position. So as the camera moves, the player will also move quite slowly and we'll end up here, right, into the next room. During this period of time, we'll also freeze the player's control and we'll stop updating enemies. We'll probably stop drawing enemies too. I don't think we need to really continue drawing them. So the game will sort of be operating in a different state, right? We won't be checking inputs. We're just going to be updating the camera position and update the player's position. So camera and player. Probably should have made that arrow gray, but whatever. So there's going to be sort of two things changing position, and we'll do it over some period of time, right? Like over 30 frames or something. We'll assign some velocity that will allow the camera and the player to make the transformation that they need to make positionally within some fixed period of time. And we won't be reading any input. Now, the other thing is I mentioned that I drew sort of green tiles and purple tiles or blue tiles for a reason. And that's because I don't want to just have the event to trigger this movement be pure collision, right? Just pure positional collision. Because if you think about it, let's say the player is walking from left to right. They step on our green tiles, which triggers this transformation from left to right to the next room. And we also cheat the player's position to move them to these blue tiles, which kind of represents the entrance of the next room. The first thing that's going to happen is that we're going to detect a collision in the new room on the blue tiles, and we'll just sort of like end up, going back and forth like this, because each time the player is just going to end up stepping on these fake tiles. Now we could cheat the player's position to be, inside the room, so we could do this extra thing. But I feel like that might look a little bit weird. I don't know. It might not. But so what I'm thinking of doing, and I think Zelda, if I remember correctly, does something kind of similar to account for enemies like bumping you and stuff. That the player not only has to collide, in this case with the green tile, but they also have to be facing in the correct direction when they step on those tiles, right? So in this case, they'd have to be facing to the right and step on those tiles. And that way, when we move them into the new room, they're stepping on these blue tiles, and the blue tiles only care about facing to the left, but in this case, the player is going to be facing to the right. So the collision won't register, and the camera movement and the room movement won't won't occur. So that's how I'm kind of thinking about it. And in this case, if the player accidentally moves to the next room, they want to move back, they just change the facing direction, right? They just face back to the left, and that would trigger the room movement back to the left. So that's kind of how I'm thinking about it right now. I don't know if this is going to work or not, but we'll give it a try. All right, so back in our terminal, and I think we need to consider the camera as like sort of an entity because it's going to have to respond to events, like the events being when the player steps on a certain tile. It's going to say, hey, camera, change your position. So I'm going to set up a file for the camera. The camera is going to move from one set of coordinates to another, and so it sort of needs to track its current position as well as where it's going, like its target position. So I think we need to think of creating this sort of camera move and have the camera itself track how far along it is in that move. Okay, I don't know if this algorithm makes sense, but I'm thinking of for our camera having two sort of associated functions. One will be sort of a set target function, and this will happen when the player steps on a tile and we need to sort of move from one room to another. We're going to tell the camera that it needs to go to some new X and new Y position, and we're going to tell it that it needs to get there within a certain number of frames. And that's all the information we're going to give the camera. So what it then is going to do is set its own target position, because again, we need to keep track of the state that it's in, or the camera itself needs to keep track of the state that it's in. It'll set its target X and Y coordinates to those new values. It'll then take the difference between those two positions. So it's going to look at its current X and Y and the target X and Y and calculate the sort of dx and dy, or the delta between where it is and where it needs to be. And I'm using abs here to take the absolute value of that. Now that we know how far we need to travel, we have this frames, and that'll tell us like how long we have to get there. And so, for example, if we needed to travel 30 pixels in 30 frames, so our dx would be, so we're moving from left to right, right? Our dx is going to be 30. We know we have 30 frames to get there. We'll divide them. That'll give us a velocity of 1, right? Because our position is updated every frame. If our velocity is 1, we can travel 30 pixels in 30 frames. Same thing for the y. Now, in the update function, I'm updating the camera's position based on that velocity, right? So I'm sort of just adding that velocity to its position every frame. I'm also allowing for some amount of extra tolerance. So if our velocity ends up being fractional or larger than 1 or whatever, once the camera gets like kind of close to that position, I'm just going to cheat and jump it there, right? Because if we had some sort of fractional velocity, it's possible that the camera could sort of overshoot the target position and just keep going forever, which we obviously don't want to do. So yeah, what I'm doing is like once the camera kind of gets more or less within range, which right now I'm saying is 5 pixels, just like set it to where it needs to be and turn the velocity off, set the velocity to 0. I set it to a tolerance of 5, and that might be like much too large, but I want to like play around with it and see how that impacts things first, and we can tweak that if we need to. So I think in order to test this, what I'm going to do is rather than tying it to the collision of the player and the tile, I'm going to map this to a button press. And so we'll use right now we have one button mapped to the weapon. I'm going to use another button and just say when we press that button, we'll tell the camera to move from one room to the other room. And we'll just sort of test this one piece and see if it works. I've made a couple of changes to our main function. In draw, I'm offsetting the camera by the X and Y coordinates of the sort of camera entity that we just made. And I'm resetting it before we draw the menu, because if I don't do that, the menu will kind of be drawn with the offset. We don't want that. We want the menu to be static, right? And what I decided to do was just in the update function. This is a super hack, but I wanted to test it. If I press the X button, I will set the camera's X offset to be 64 frames, or I'm sorry, 64 pixels to the right. And I'll also give the camera 30 frames to get there. And so if we have a look at what happens when we do that, we can see that it kind of works, right? That slide actually looks pretty good. One thing that obviously isn't working is that the room to the right is not being drawn. And you'll remember earlier, we sort of set the map function to only draw based on the current room. I think given that we're only going to do a few rooms for this, we can probably just change this to draw the entire gosh darn map, like just draw all the rooms. I don't think there's any like real issue with doing something like that with a smaller map. So I'm going to make that change now just so this looks a little bit more sensible. Okay, yeah, this actually looks not too bad. So we can move around inside this space, and obviously the camera's not updating itself. And again, like we'll have some sort of collision trigger to make the camera move. But if I move to this room and then I just press X to trigger it manually, that looks like pretty good. So I think we can also work on having this happen based on collision rather than me doing it with the button press. I can't imagine playing a Zelda game where pressing the A button is what triggers, room transitions. The other thing that I forgot to mention when we were looking at the diagram before is notice how this adventurous baddie has wandered into our second room. We don't want that to happen, right? We want the baddies to sort of remain in each room. And what I'm thinking of doing to make that happen, go back to paint here, is that so we can, just like we set collision on the blue walls so that the baddies don't walk through walls, we can also set collision on other kinds of map tiles, right? So when we make our sort of special green and blue map tiles, we'll also make sure that the baddies collide with those so they can't like walk through from one room to another. The player will be able to walk on them just like regular tiles, but the baddies will not be able to do that. And I think that will solve our adventurous baddie problem. All right, I want to clean up a couple of things graphically here. I'm going to add some extra walls to the corridors because I sort of don't have walls right now. And also I'm going to remove the 1 and 2 tiles from the rooms. I don't think we need those anymore, so let me take care of that. All right, and while I'm here, I'm going to go ahead and make our sort of room shift tiles, and we're going to color them differently just for some sort of visual indication that they are special. Actually, I guess let's do 4, so we'll do one for left and right and one for up and down as well. I've also set the second flag on these 4 tiles. This is going to help us deal with the baddie collision issue that I was just talking about how baddies can kind of just like wander out of rooms. We're going to set it up so that these tiles will stop them from walking. And we'll test this by dropping a few tiles onto the map and sort of making sure that as the baddie AI wanders that they don't walk over these tiles. Let me check that out now. All right, so I've updated our baddie collision check to check not just for the first flag being set, but for the second flag. So right now we're treating the colored tiles, so sort of purple, green, yellow, purple, whatever, the colored tiles. We treat them the same way as we treat the walls. So hopefully if a baddie encounters one, they will sort of update their state and not walk through it. So I'm just going to let the AI play for a while to see if it'll work. As you can see in the map here, I've sort of like put up this wall, Hadrian's wall of purple tiles here to prevent the baddies, hopefully, from walking over it. So let's see if that worked or not. Okay, yeah, I mean, just based on this arbitrary evidence, it seems like they are not able to walk through the wall, which is good. So we'll use these tiles in the doors, and that should prevent the baddies AI from walking them out of the room. I am your god. All right, so one quick change I want to make is around our update function. Right now, we sort of just have this one update function that's called no matter what is going on in the game. I want to abstract that out a little bit. So you can kind of imagine like different game states. Right now, we only have our player walking around the map. Nothing really changes. There's no menus. There's no anything like that, right? We can imagine quite easily that there would be a title screen, sort of an ending screen. There may be sort of different, level ending things that happen where we want to do things like block player input, right? Or render some different thing to the screen. So instead of just putting all this stuff in update 60 and doing some if statements to see what the heck is going on, what we'll do is we'll just define some general update function or some variable that we're going to use to point to whatever our current update function is. So right now we just have this one in update 60. So we'll call this game update. Actually, we don't have to use the syntax. We'll just do this. And we'll set our double underscore update to be game update because we're just going to point to that function for right now. And we'll copy the current contents of update 60 into here because this is like our main update loop. And then in update 60, we'll just call whatever the current update function points to. You can imagine we would have some other update function like title update. And we'll do this later, probably for some sort of victory screen where we're just printing the title. And so during the period of time where we're displaying the title, rather than calling game update here, we'll set this to title update. And then when player presses start, we'll set this to, we'll reset it to be game update, etc. So now we can sort of change where our update function is pointing and sort of isolate the logic for each game state in that function, right? Rather than having to put all of that stuff in the update 60 function, we can break it into separate functions. The reason I want to do this is actually because I'm going to keep the button triggered room shift in place for right now. But I'm going to create a different game state because I want to not allow for player input while that's happening, right? So once we press B, we're going to kind of stop the world, advance the camera to the next room. And during that time, we don't want kind of other stuff to happen. We don't want the baddies moving around. We don't want the player moving around. We're just going to stop everything else. So let's work on that. Okay, so the only thing in this update function where we kind of move to the next room is we're going to update the camera, obviously, because we want the camera to move. And we're going to update the sort of, we're going to process what's in the queue. And the reason for that will become apparent shortly. So if we go back down to where we're processing our input, oh, whoops, which is actually up here now. Let's set our update to be our new room or change room. Next room. It was called something. Next room update. So we'll change our function pointer to be the next room update. So let's test to this point and see if it works. We're going to get stuck when we do the room change, but we'll just let ourselves get stuck. Okay, great. Yeah, so the sort of room change thing still worked. The problem is that we can't do anything at this point, right? The game's sort of soft locked. The reason is because we're still calling this next room update function, and all we do there is update the camera and process the queue. And the camera's done updating and the queue is done processing. So what we need to do at this point is switch back to our original update function, our game update. So we need some way to know when that happens, right? like when do we switch back? And the event that triggers that is going to be when the camera reaches its destination, right? At that point, we want to be like, okay, camera's done. Go ahead and do the game update stuff now. And this sounds like a location that we want to have another topic. In this case, maybe camera move finished. We'll call it cam move done, something. This, however, raises the question of like who gets this topic, or who, I'm sorry, who subscribes to this topic. Let me think about that for a minute. What do we want to do here? I think I want to have some sort of game state manager that can intercept these things and sort of manage which update method is being called. So let me create a new file and a new entity to handle that. All right, so I've created another manager. We'll call it the game manager, or game M, and it needs to handle this sort of camera move done event. And in this case, all we want to do is set our update function back to game update. Accessing all kinds of global state here, but it's going to roll with it. So now we need something to actually create the event on this topic, right? Which is going to be the camera. And in our case, since we're only moving in one lateral direction, that is, we're either going to move the camera from left to right or from up to down. The thing that's going to trigger the event is whenever either the X value or the Y value reaches the target location. So here we'll sort of fire the event, and also here we'll fire an event, because either one or the other of these is going to trigger, right? It doesn't really matter which one. I'm going to unify my naming here, so I realized I was all over the place. Okay, so we're adding the event here. The queue will be processed here, and that will end up with an event coming here to our game manager, which will set the update function back to game update. Now that we have this game manager, we could also include the sort of this switch. So we could pass any input to the game manager and have it set it to next room update. I don't really feel like doing that right now, so we're just going to leave it for later. But let's load this and see if it works. So what we would expect to see here is after the room switch happens and the camera stops, we're able to move the player again, right? Input should resume. Oops. Oh, we didn't load game manager into the thing here. All right, let's see if this works. Oh, we took some damage. Okay, great. That worked fine after we loaded the file. Thanks all for watching this one. I know the rooms are taking quite a while to get working, but we're actually pretty close now, so don't don't lose hope. I want to say this is probably the most difficult part of this implementation. So once we're done with this bit, the rest will be a lot more sort of downhill, so to speak. Anyway, if you're finding these videos helpful, please consider subscribing, or you can just comment to say hi. Those are also very much appreciated. And I hope your game development journeys are fruitful, and I will see you all next time.